Sample space graphs are a really good way to list the number of outcomes in a two-step experiment, but more importantly, you can actually list the actual outcomes themselves, and that's where I think these really come into their own, especially if there's something that you need to do to work out those outcomes. So this is a good example of how you can use a sample space graph. I toss 2 dice and I add the scores. Find the probability of a score of 6 or more. Now, off the top of my head, I know that when I toss one die, I can get 1, 2, 3, 4, 5, or 6. And I know when I toss the other one, I can get the same. So potentially, the lowest score I might get is 2, and the highest score is 12. But the actual probability of 6 or more is not something that leaps straight to my head, because I know it's more complicated than that. Now, if you were to draw a tree diagram for something like this, you'd end up with a bit of a mess, because there's 36 outcomes, aren't there? So I've got 1, 2, 3, 4, 5, or 6 could happen on the first toss. But see what happens when I need to add the second toss. There's going to be 6 branches here, 6 branches here, 6 there, and I'm going to have 36 rows here where I have to add the numbers. And it's just going to look like a muddle. So instead, it makes a lot more sense to list the things that I could get on one die down the side and the things that I could get across. And then this becomes a little chart where I can actually write all of the outcomes that I might get. Now, I know there's 36 possibilities, and obviously that's going to be 6 rows of 6 here. So if I have a 1 on the first dice and a 1 on the second dice, that's going to be 2. Obviously, you can really quickly and easily create these rows. A 2 with a 1 will give me 3, and a 2 and a 2 is 4, and away I go. The patterns are very straightforward. Now, when you start making one of these, it's tempting just to go, oh, look, this is so easy, it really feels like primary school work. Can't I just sort of guess? But it's really easy also to make a mistake on a question like this, and actually writing them out is probably the best thing to do. So let's go ahead and finish this off. 6, 7, 8, 9, 10, 11, and 7, 8, 9, 10, 11, and 12. A little bit messy. So if there's 36 things that could happen, I can easily see that things sort of have diagonal patterns through here, don't they? So everything that's 6 or more is from here down. Probably quicker to count the things that I don't want and subtract them from 36. So there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 things that are not what I want. So there must be 26 that are. So then if there's 26 favourable outcomes, remember we work out probability by saying what we want on the top of the fraction, and there's 26 things that are favourable out of the number of things that there are altogether. And if we can, then we should simplify that fraction. So halving top and bottom, I get 13/18ths. Now, sample space graphs have a big limitation. You can only really easily do 2 dimensions. I mean, maybe you could use some software to put a 3rd dimension in, but it's going to get too complicated. But as long as your experiment is only a 2-step experiment, there's lots of sort of dice games and dice questions that could work really well for something like this.